In this video, we're going to look at beta decay, another form of radioactive decay from an unstable nucleus. In this case, we have a nucleus that is unstable because it has too many neutrons. So here's kind of a good little equation for what's happening in beta decay. In the center here, we've got this neutron, this extra neutron, that really decays into a proton and an electron. Which is interesting because a proton and an electron would be neutral. You've got one positive, one negative. An electron doesn't have substantial mass. The mass of a proton is about the same as the mass of a neutron. So here's what we're looking at. An unstable nucleus that breaks down a neutron, forming a proton and an electron. Your atomic number then will increase by 1 because the atomic number is the number of protons, and we are forming another proton. The mass will stay the same. Say in this little box we've got kind of a picture, a visual of what's happening in beta decay. And so again, here's one way that we could write these nuclear symbols. We could either have the word hydrogen 3 or helium 3, or you might see the nuclear symbol, which would be hydrogen. The mass goes up on the top, the atomic number on the bottom. Now this is not the most stable form of hydrogen. Hydrogen mass 1 is the most stable and most abundant. So this would follow suit that this hydrogen 3 is probably not a stable nucleus. So we are going to decay, forming helium. Mass 3. The mass will stay the same. Protons and neutrons have about the same mass, but one of the neutrons has turned to a proton. So that's why my atomic number is now 2. Element number 2 on the periodic table is helium. We would then emit a beta particle, which is really just an electron. This guy right here, that's your beta particle. A beta particle is essentially an electron. It's a little particle with no substantial mass, and it does have a negative charge. So in this picture, we could kind of put some little symbols in. Let's call the red dot the proton, since there's only one. So here's my proton, which is positive. So the blue dots must be my neutral neutrons. So put that in there. And then we decay. We still have 3 particles in the nucleus, so the mass is still 3, but one of the neutrons has turned into a proton. So I have 2 positive protons and just 1 neutral neutron. And then here is my electron. I'll put a little negative in there. There's my negatively charged electron, my beta particle. Now beta radiation is a little bit more penetrating. It can be stopped by a thin sheet of lead. As far as your health goes, the beta particles can penetrate into your tissues. They're really tiny. I mean, they're just tiny little electrons. So they may not do a lot of damage, but they'll penetrate farther. So sometimes I think of it as like, you know, maybe I'm rolling a golf ball on the lawn, where I can roll the golf ball pretty far, but it's a lightweight particle, so it's not really going to damage the grass. That's kind of how I think about these beta particles. They're small particles, so they can travel a little bit deeper through your tissues, but they're not going to cause a lot of damage. Here are some other good examples of beta decay. If I see it as an equation, again, I like to leave the element symbol kind of toward the end. So I've got element 46. Element 46, some palladium with a mass of 109. This is a particular isotope with a mass of 109. I know it's beta decay because I see the electron. If there's ever a question that says, what kind of decay is this? When you see the electron, that's the beta particle. The alpha particle from the last video, That was the little helium nucleus. The electron is the beta particle. So let's see what we got. The mass is going to stay the same. Emitting an electron does not mean I'm changing the mass substantially. So the mass is still 109. However, I'm forming an extra proton. I'm taking a neutron, turning it into a proton. So your atomic number is going to go up by 1. So now I'm at number 47. Then I look at the periodic table to find element 47. 47 is silver. I do the symbol last. Now again, you can kind of make sure that this all adds up. The mass 109 plus 0 is still 109. And then on the bottom, 47 minus 1 is 46. Not bad. Let's say we have some gold. I have an unstable isotope of gold. The mass will stay the same, 198. But if I turn a neutron into a proton, the atomic number goes up by 1. This will be element 80. I look at element 80 on my periodic table. There she is, mercury, Hg. The mass, 198 plus 0 is still 198. And then on the bottom, I have my 80 minus 1, 78. These aren't too bad. After you practice a few, you just need a periodic table, and it's really not like calculus or anything too wild and crazy.